or something. All right, welcome to our review session. If there's new material today, we're going to learn it in the context of the practice problems. Okay, I'm going to put a practice problem under here, and then you guys are just going to work on it in your notes. Don't copy the whole thing down. Okay, the problems come in 3 different formats. Multiple choice, matching, and the weird ass the weird true and false thing. Okay? So, we got this problem of what happens, the one on the right, the matching problem. What happens when the following are dissolved in water? Your choice is 20 through 23. Okay? So, Cal, do you have a YouTube? Yeah. Give me your YouTube username right here. Go ahead and share the last video. Use it. This is multiple choice, but it's a matching problem right now. So like 20 will be A, B, C, D, or E. Oh, just like what we do. I'm working out of the Kaplan book right now, guys, which is the most realistic of all of them. Yeah? What? 23 says forms an ionic solution with a neutral pH. Sorry about that. Alright, there are certain key words in all this stuff that you want to pay attention to. That you don't have to. You want me to say answers?
Your attention, please. I think if you received it a few minutes ago, you caught the little joke that we had here. There's no need to evacuate. Everybody can return to the buildings.
Who's missing?
A short little terminal.
I've never felt an earthquake in the 10 years I've lived in a stupid city. I know, but I want to. I'm super curious. I was in Sacramento in '89 in the 8th grade, 1989. I was coming back from a basketball game. We got home and our pool was empty in Sacramento. We didn't feel anything. Crazy, huh? All right. Take one more minute. Okay. Don't leave any blank, by the way. Just right answers. So, forms a strong base. F the word strong. And what's the answer? Base. So what's the answer? E? A. The answer is A. Bases are things with the hydroxide. Basic solutions, base. Okay, you're thinking of a reaction. They're just saying when you put it in water, so when it dissolves in water, it's OH minus and A plus becomes a solution. Yeah, so what they're saying here is just simply when you put NaOH in water, it becomes an aqueous solution, and they become their ions there, and the pH becomes greater than 7. Can you see? Can't see what I'm doing, huh? Whatever. Okay, so what about forms a weak acid? This is a tricky one. HBr is one of our strong acids. The answer is D. D is acetic acid written in a different way. So acetic acid can be written that way, or HC2H3O2. Okay. What? They just, yeah, so acetate can be written C3HCOO minus or C2H3O2 minus. You might see it on a polyatomic chart that way. So if you write it that way, they put the H at the end, just because it looks cleaner. This is kind of the organic chemistry way of writing it. You don't got to worry about that as much. But the one thing just to remember is we got rid of OH. We know that's not the answer. O2 can't be an acid, and B can't be an acid because it's not H. And all you needed to know at that point then is C is a strong acid. HCl, HBr, HI are the three binary strong acids. So 21 is D. So what's 22? C. Now 23, you don't worry about the pH. What's the word that's going to be the ionic? Ionic solution. So what's the answer? D is the answer. CSCl, ionic, metal and non-metal. So if you looked at O2 and it said ionic solution, first off, O2 is a gas. I'm not going to go into the solution. Second of all, ionic means metal. So write that. Ionic means it starts with metal. Is that okay, guys? All right, 29. The oxidation state of nitrogen is most negative in which of the following? Sorry. The oxidation state of nitrogen is most negative in which of the following? N2, N2O, NH3, NO2, NO3. Do the X thing. Did you guys all get it? Okay. Answer C. All right, N2. What's the oxidation state in N2? 0. N2O. If you stop and think about it, O is negative. So that means N has to be positive. That means that N is positive in D and E because O is negative. So that means that in C, H is always positive, so N would be negative. Okay? So that's how it works out. That's an easy way of doing it, that one.
So we can always assume that oxygen comes before when you consider.
Okay, so the best way to do it in terms of oxidation numbers is whoever they're asking you for, okay? Everyone else. Whoever they're asking for, everybody else follows the periodic table. Okay? What do you think you're looking at? Yeah, we'll go with 23. Okay, but let's do 31 right now. Let's do 31, 32. And then. And actually, when you do 31, there's a couple, I want you to also think about why some of those choices are ridiculous. Okay? Like why some of the answers just can't be true based on what we know from last unit. Alright, what's the answer to 31? A. Okay. Water is a strong electrolyte. Remember what I said in that first lecture? Electrolytes are things that produce ions and dissolve in water, right? Water doesn't do that, it's just water. Sodium sulfate quickly precipitates. What is in that makes it not ever precipitate? Na, okay, or NO3. A volatile product is formed. You're just forming a salt in water. Volatile means flammable. Right? We're not producing anything flammable. Sulfuric acid is a very strong acid. That's true, but that doesn't tell us why the reaction goes to depletion. The reaction goes to depletion because you're neutralizing, you're producing water. What's the answer to 32? D is the answer. In an electron configuration where something goes to the excited state, remember that electron jumps out to the other area. So the electrons are staying more, everything's the same, but the electrons are just jumping to another region. So let me draw like neon. Are they talking about neon here? Okay, so neon is 1s2, 2s2, 2p6. So neon in the excited state might look something like 1s2, 2s1, 2p6, 3s1. See what I mean by that? That electron that was in the 2s jumped all the way out to the 3s orbital. Okay, but it's still neon. The only thing that's changing is the electron configuration. Oh, let's talk about this thing. You asked about this. Okay, this is a way of categorizing solids, okay, specifically ionic compounds, and they're asking this question, but I know that the only one they require you to know is a crystal. And when you have a crystal, like an ionic compound, it's going to be a lattice, it's called a lattice structure. Okay, so the answer is C. So crystal, like it forms what's called a lattice, or you might have ever heard the term a crystal lattice. Okay. All those other ones, I can promise you, you're not going to see. Okay. So they just want you to know here if what the basic structure of the crystal is. So like a sodium chloride crystal, a salt crystal. If you look at it under a microscope, you can see a lattice of NAs and CLs. Okay. Oh, okay, let's start 41. Equilibrium from last time. How will the equilibrium of the following reaction be affected if more chlorine is added? We all have it. Let's have the last principle. So remember, it reached equilibrium. Now you're adding again. Okay. Up, up, and away. So you increase CL. Where's it going to go? Left. Answer's B. An easy equilibrium question can be? Ooh. Answer's B. Could you guys all draw the equilibrium constant expression for that reaction? KEQ? Go ahead and do it. And I have to do the 330 so you guys That's so weird in an earthquake today. Okay, so for that first one, it was up, up, and away. And for that second one, KEQ, it's going to be, is it reactants over products or products over reactants? Products over reactants. Raised to the power of their coefficient. Boom. Okay, why don't you guys start 43? what mass of sodium carbonate, and they gave you the molar mass, is needed to make 120 milliliters of a 1.5 molar solution. So straight out of Unit 1. And do without a calculator. Okay. Try and estimate it without a calculator. Oh, shoot. So when it's multiple choice, remember, because the answers are there, don't get too caught up in having to go through and get the right. Like, start looking for trends.
Marissa Escamilla, please report to the main office.
You guys get an answer? I mean, you guys could kind of do this one just by like eyeball numbers. Like, what do you have to multiply together first? 120 and 1.5, but are you multiplying 120.12? So what are you going to call it instead of 0.12? Call it 0.1. If you call it 0.1, then the answer is 0.15, but it's going to be a little bit bigger than 0.15. So something a little bit bigger than 0.15. Now, we have to multiply that by 100, right? So 0.15 times 100 is 150. No, it's 15, right? But if the answer is going to be a little bit bigger than 15, so 19. Boom. All right? Did you guys get that, though?
I wouldn't trust myself.
Okay, however, if you did that logic, it ain't 19,000, right? It ain't 589, and it ain't 295, right? And it's definitely going to be something that's a little bit bigger than 15, and 9.5 isn't. So, you don't trust your logic, but still, it's pretty damn good logic if you look at the way the numbers work out. You don't have to. All right. All right, since we're doing stoichiometry, since we just did a conversion problem, let's see what you guys remember from two things from last year. Let's do 55 and 56. 56 is a gas problem, and 55 is a limiting reactant stoichiometry problem. But I will, I want to tell you something. Okay? You don't get excited. So they gave you 88 grams of C3H8. I can definitely tell you probably a whole number of the moles of it. And they give you 160 grams of O2. So for limiting reactants, remember, all you do is you do the problem twice, and whoever made the least is the answer. That's all you have to do. So they say 88 grams of propane and 160 grams of oxygen are allowed to react. How many grams of CO2 will be formed? So do it twice, all the way to CO2. But I'm telling you, like, you get the molar masses, and I bet those numbers are whole numbers of the molar masses. and then 56. I'll zoom in on 56. Yeah. Yeah. Very. Yeah.
Okay, I think this is against the rover. Can you rip the periodic table out of the book and have it in front of you? Or is that like...
Yeah, so what was it like? Was it the test good?
It's like in the very... But then like the chem test is like in the middle. Yeah. So like once you get to the back problem, you have to like flip back pages.
That's a really good question. I asked the proctor, I don't know.
I don't think
They probably went to test station.
Well, I would go in there though. If you guys want to memorize, I would go in knowing CO2 is 44. Okay, water is 18. Glucose is 180. Like what are the ones that you see a lot? You know, C6H12 O6 180. CO2 44. I think C3 C3H8 is also 44. So here's what makes this problem easy. C3H8 and CO2 have the same molar mass. So those things are going to end up, yeah, because 36 plus 8 is 44, and then 32 plus 12 is 44. O2 is 32, that kind of stuff. And then see if you can do 56. I think you guys have taught partial pressures last year. You guys think 55? E? You got C?
Should be.
You guys get C?
It should be C, but I got half of that.
Yes.
Who's limiting reaction first?
Two.
Okay, so you take 160 divided by 32, right? What's that give you? 5? Okay, so you have 5. So now, in the mole ratio, you should have, is it a 5 in front of the O2 in the balanced reaction? Okay, so then you have 5 multiplied by 3. So 3 over 5, so 5 times 3 over 5, so then it just becomes 3. And then 3 times 44. Alright? Okay, so the answer is C. So you do the same thing with the other one, and you end up with a bigger number. Is that true?
You get 264.
Okay, so whoever gave you the smallest number wins. 56? Can you guys help me with that? I'm not really sure what's going on there. I mean, it seems like it's a pretty easy problem. Okay, you have a 200 milliliter flask, and it contains oxygen at a pressure of 200, and you have a 300 milliliter flask, and it contains neon at a pressure of 100. The two flasks are connected so that each gas fills their combined volumes. Assuming no change in pressure, what is the partial pressure of neon in the final mixture? What did you guys get? What's happening right now? Stop moving. Jesus. What's the answer? Did you guys learn partial pressure last year?
Yeah.
Well, you can learn it the big, stupid memorizing way, which is PV equals nRT, and then you could say PV equals the sum of the moles RT, if there's like more than one gas in a container.
Oh, yeah.
You know what I'm saying? Or if they just gave you, if there's a container and they gave you the individual pressures, the total pressure is the sum of all of them. But the thing is, they were in a different container initially. So one was in a 200 milliliter flask and one was in a 300 milliliter flask. Their wording is confusing. Yeah?
I have to go.
Okay.
But, is this gonna, like...
It'll be recorded and I won't make it private.
Oh, okay.
You're welcome. See you later. Thank you. What's the answer? Should we look at the answer? Can we search for it? I mean, I know how to solve it, but I don't want you guys to do it the complicated way. So I'm feeling there's an easy way to do it. So 56. Oh. It's A. Okay, so they use Boyle's law. And they use Boyle's law because they said the temperature is constant. So you could use P1 V1 equals P2 V2. And they did. Oh, I get what they did. That's tight. Okay, let's look at this. They did two individual. That's cool. Okay, do you guys remember Boyle's law? P1 V1 equals P2 V2. The reason we could do Boyle's law here is because we're assuming no change in temperature. Okay, so they want to know what is neon at the end. What is the partial pressure of neon at the end? So the partial pressure of neon, okay, is going to be the pressure of neon divided by the total pressure. Okay, I believe so. No, hold on. What am I getting? I'm thinking the mole fraction. Oh, yeah. It's way easier than that. I'm making it too hard. Okay, all you have to do is do P1 V1 equals P2 V2 for neon, and you got to get P2. So what's P1 for neon? For neon. Neon 100, and what's V1 for neon? 300. So 300 times 100 equals P2. And what is V2 for neon? Yeah, why is it 500? It's a total volume, right? So they go into that, and then you end up getting 400. You end up getting 3,000 divided by 500 to get P2. I mean 30,000 divided by 500. 60. Yeah. Is that okay, guys? Okay, so here's the deal. Write that. Constant temperature. Whenever they say that, write down Boyle's law. P1 V1 equals P2 V2. Someone had a question? Anyone have a question? Looks good? All right, I want you guys to do 46, 48, 49. So 46, 48, 49. 46 is asking for the oxidation number on chromium. When chromium metal is used to form that, the oxidation number changes from what to what. In 48, they're asking why do all halogens have the same reactivity, and in 49, K plus and Cl minus have the same what? But I like to, so today the ones I'm going to give you are going to be not the like random ones that are like basic, like weird info. We're going to do all kinds of ones you really need to get today. And then in closer proximity to the test next week, we'll do kind of the random questions, like more lattice structure stuff. You guys get them all? They're pretty easy, okay? Chromium changes. First off, chromium metal, what does it have to be initially? 0. So the answer can't be B, C, or E. So now you're doing the x thing. So you have 2 plus 2x minus 14 equals 0, so CR is 6. The answer is D. Alright? 48. All halogens have the same reactivity because yeah, this is tricky. What's the answer? C is the answer. So let's go through why it's a subtle thing. I'm going to teach you something new, okay? They have the same number of protons. That's ridiculous. Of course they don't. To be the same number of protons, what are you if you have the same number of protons? Same element. That's ridiculous, okay? They have the same number of electrons. That's ridiculous. If AT had the same number of electrons as fluorine, AT would have a charge of negative, like, 76, right? Or no, positive 76. That's ridiculous. They have the same outer shell electron configurations. They have similar outer shell. Yes, they all end in something P what? 5. So if they said the same, it's wrong. Similar, there's no way to argue with that. It is XS2, Y, P5, right? XS2, Y, P5. They have the same valence electrons, true, with the same quantum numbers, false. So watch out for the word same and same together. The quantum numbers is another way of doing the electron configuration. What that's saying is they have the same electron configuration. So quantum numbers equals electron configuration. Think about it that way. And they have the same number of neutrons. Ridiculous again. Yeah. Yeah. They don't have the same electron configuration. It's similar electron configuration. All right. K plus and Cl minus. Do they have the same atomic weight? No. 35 and 39 are not the same, and electrons don't weigh anything, so it doesn't matter. Do they have the same electron configuration? Yes. Yeah. Because in order for Cl to be Cl minus, it needs to gain 1 electron, which makes it like argon. In order for K plus to be K plus, it loses 1 electron, which makes it like argon. So both of their electron configurations is neon, 3s2, 3p6. Ionization potential, number of protons and neutrons, will they be the same element if they had those the same? And they're obviously not the same atomic radius because one's the hell over there and one's way over there. Okay. Okay, here's the way I think about it. It is the protons in the nucleus, okay, that are making it pull onto its electrons. So let's look at things horizontally. Let's just look smack at the transition metals, okay? Look at Ti, okay, and look at Cu. Both of their valence electrons are in which energy level? Ti and Cu. But that's orbital. What energy level? 3. So think of that as the ring. Those electrons are both in the same ring. Okay? Which one of them has a stronger nucleus? Cu. Cu has 29 protons in its nucleus. So those 29 protons are pulling on that third ring way harder than the other ones. Okay? So the stronger the nucleus, the stronger, it's called the Z effective. You'll hear it used that way. The stronger the Z effective, and the word Z refers to the nuclear charge. So the nucleus is pulling on that ring with much more force. So it ends up being smaller. Okay? The other one ends up being bigger. And that's why it's got a greater electronegativity and ionization energy and electronegativity. Random questions. Let's go and look at the actual practice test. Okay, you know what? Let's do some of these weird ones. Alright? Why not? F it. Alright. Okay. Let's do 108, 109, and 110. Do you guys remember how I told you to look at these last time? Okay. So, you're going to fill in 3 bubbles. True, false, and correct example. Let me show you how this sheet looks first. It looks like this. Okay? So that's what you're going to see. You're going to see there, there, and there. Okay? All looking at them individually. This is if this statement corroborates that statement. So when is the only time you're ever going to even look at correct example? When one of them is true. No, when they're both true. Yeah. Sorry, I'm retarded. You got me. Alright. Okay, try these ones out. And you can use your notes that you've taken so far in this. 108, 109, 110. How do you guys remember what for, right? Yeah. Alright, let's go through each one individually. 108. A basic solution has more hydrogen ions than an acidic solution. False. 19. Atomic radii decreases going down a group. False. Things get bigger as you go down. Okay, radii, radius, those are the same. When an ideal gas is cooled, its volume increases. False. So, might have remembered from this year, I think I told sister to show you guys this last year. If any of you guys had sister. Okay, PTB sticks. Okay, you can do it on your pencil, do it on anything. P, T, B. Okay. Whatever variable is not mentioned, or they say is constant, you put your finger over. So in this one, when an ideal gas is cooled, its volume changes. So which one's not mentioned? P isn't mentioned. It's cooling refers to temperature. So P isn't mentioned. So I put my finger on it, and I change it, and whatever happens to the variable along with it. So cooling means temperature goes down, right? What happened to volume? Went down also. See that? If temperature goes up, volume goes up. What if T is constant? Hold it in the middle. What happens to pressure if I decrease volume? Pressure goes up. If I increase volume, pressure goes down. Okay? Write PTB on your pencils before you walk in. Or cut out a little piece of the thing right PTB when you walk in. No one's going to do anything. Okay, last year when I walked into the AP test, I remember I peeked in on the window and I saw one of someone. So tight. Alright? So, false. So are any of these going to have correct examples?
Why are you using pen?
No. pH is defined as the negative log of the concentration of hydrogen ions. True, I gave you that equation last time. The higher the atomic number within a group, the smaller the atom. True, I just told you that, right? Okay, so you can think of a group. They're not saying if it's horizontal or vertical. A lot of times you'll think of like, you can think of this as a group or this as a family. It's kind of ambiguous. But actually, I don't know what they're thinking of here. Let's go back and look at that. What's it called? What is this? What is this? This is a family. They don't use that language anymore. What's this, a period? No, the language isn't used anymore, so I don't know. It's like, so either way, horizontally, more protons, smaller. Vertically, more protons is going to mean bigger, because that means you're just going down. So I'm not sure what they're looking at here. What?
Groups of like acid, like electron.
No, that doesn't mean orbital groups, because those orbital groups refer to where the last electrons are. It's like the last electron and all the alpha atomic matter fellows are in S. Temperature and volume are proportional. True or false? Hold on. When temperature goes down, what happens to volume? Goes down. Temperature goes up, volume goes up. What are the only two that are inversely, or with P and B? That's Boyle's law. Proportional. I mean, when they say proportional, they're referring to directly proportional. Yeah. That's also a poorly written question. They should say they're directly proportional. That's what they do. That's to draw a graph. The graph will either be like this or like this. Yeah.
From the statement for 110, does that have to do with particles?
No, that has to do with, yeah, it does. Let's think about it conceptually. Okay, when they say an ideal gas, all they mean is that the gas is behaving according to the ideal gas law, which means that the particles are so separated from one another that we can assume that each individual particle actually isn't taking up any space. So what that means is that the volume of the gas is equal to the volume of the container it's in. So, I mean, if it was taking up a lot of space, the volume of the gas, how much space it takes up, would be less than the container it's in because itself would be taking up space. Kind of you getting in a bathtub, right? The volume of water rises when you get in, so you have to subtract your size to find the volume of water that's in there. But in an ideal gas, there's so much space in between the particles that we assume that they're negligible. So yeah, when you cool it down, the particles aren't moving as fast, okay? And if they're keeping pressure constant, in order for the pressure to stay constant inside, the volume's going to decrease. Like, think about, you have a balloon, right? And if you cool down what's in the balloon wrinkles, right? But that's because the pressure's dropping also. But if you wanted to keep the pressure the same, meaning when I poke the balloon, it would push back on me with the same force, but I made the gas cooler. Well, the cooler gas is going to be moving not as fast. So I've got to make the balloon smaller, okay, in order for that whole thing to stay the same, right? It's like if you guys were bouncing off the wall in here, and then you guys started moving slower, and these walls are like a balloon, whoever was feeling the outside of the balloon would feel less pressure, unless you made the balloon smaller, and then you could feel the same pressure. So it's right. All right, try 115 and 116, and we're going to stop on those ones because I got to go. Oh, it's a messed up one. Okay, here's what I would do here, guys. Let me make it easier on you. Based on what we're looking at here, that polyatomic ion has what charge? -2. So pull the polyatomic ion out and do Cr2O7 minus 2 to get the Cr in there. You know what I'm saying? So like this here, okay? This came from Cr2O7 that was -2 and Al that was 3+. Would you agree with that? So why don't you just take this thing out and do the 2x plus 7 minus 2 equals -2 with just this. Instead of doing this whole crazy thing. It's going to be the same thing because that came from that. Yeah?
Are there any true, not a...
Yeah, definitely. Okay. I can say that Mr. Musallam is a man, and I can say Mr. Musallam has big lips, but it doesn't mean to both true. It doesn't mean that's why I'm a man. I'm a man because of a white chromosome. Right? That would be the true first example. Alright, the oxidation state of Cr in this is 3+. True or false? False. What is it? No, it's Cr2O7, so it's here. Plus 6. Because 6 times 2 is 12. 12 minus 14 is equal to -2. In a neutral compound, the sum of the oxidation numbers for all the atoms must equal 0. True. That's how that equation Thumbs up. Now, entropy. Is entropy delta G, delta H, or delta S? Delta S. The entropy of a solid increases when it's dissolved in a solvent. What do you think? True, right? The particles are going to separate. Messiness, right? So it becomes less ordered. True or false? True. Correct example. Boom. All right? Okay. So let's leave it on that. We'll pick up. We'll do more practice problems next time. What I'll do is I'll only pick practice problems for concepts we haven't looked at yet as a way of teaching you those new concepts. Okay? And then, so why don't we schedule a time right now for next time? As usual, I can't do Tuesday. So I could do. Well, I'm just going to tell you right now. I can do Monday. Is Monday? No, hold on. Is Monday a white? It's a green. It's green. Hold on. No, I can't do Monday. I can do Thursday. Okay, I can do Thursday. Can you do that? And then I can do Friday at lunch. Why don't we do Thursday, Friday, and then at Friday at lunch, we'll do like a mini practice. Okay? Okay. Next week, I can do Thursday and then Friday at lunch. Yeah. Yeah, I'll send you the private YouTube video, and then everyone gave me their passwords, right? Usernames?
Oh, you want to know what?
Where's that little other little server?
Yeah,
Sorry. Alright, now I'll send it to everyone. Give me your username. I'll send you the one that's private right now, and then this one won't be private.
Alright, so it's going to be on the.
It's going to be on our website under miscellaneous. You just go to.
Alright.
Okay, so we're meeting Thursday after school. If it's a white day or something, we'll just do right after. So in the meantime, you guys start like developing the things you have questions on. What I would say is, I bet there's going to be a lot of gases. So I would go through and look at like gases from last year. From last year? Gases, stoichiometry, basic like isotope formula stuff, electron configurations. We're doing Lewis structures in class right now. We're doing resonance. Next, we're going to do orbitals, hybridization, polarity, London forces, weak interactions. You're going to get all that before the thing. Okay? So if you look at anything and it talks about like London dispersion or polarity or all that kind of stuff, that's the standard for this unit. So you're going to like watch me and destroy that because that's like going to be your head. You might want to look at simple shapes like tetrahedral and all that kind of stuff. But I'll still tell you that stuff. So.
Do they expect us to know
The basic ones. So the basic ones are tetrahedral, planar, pyramidal, linear, and bent. No. No. What you need to know for me is separate. I want you to be able to explain the shape. Like today's warm up. Who did I have today? The opener today is exactly like what we need to know. The unshared electrons are what cause the shape. And all the other bonds. The bonds trying to get away from the unshared electrons. Can somebody find out if skipping is, how does it work on this?
What's 0?
Is it 0 and then you get marked off? So it's prison rules, it's like 0, you nothing, mark it off, you get -4. That's the rules? Okay, AP test ain't that way. It's net answers right. Okay, so you just want to guess. Okay, so guys, you all know if you can nail it down to 4 out of 5 guess, because then you have a 1/4 of a chance of getting it right, or you break even at the worst, statistically. All right. Bye, guys. See ya.
Are we gonna